So maybe let me know, like, if I'm moving again, let me know, because I need to skip to the next slide. I was just basically talking a bit about myself. So I'm based in Dunedin, which is in the south of the South Island of New Zealand. And my focus is on visual computing. And here in particular, I'm interested in how to use visual computing for sports and media. And we do lots of research in the space of extended reality, AR, and also VR. I was just briefly talking about like our small AR Snapchat filter here on the, here on the right-hand side. So if you're interested in visiting me or my lab, so just come to our department, and you will have like a nice overview where everyone is sitting. So now I'm just asking the audience if I'm switching to the next slide, is it? Am I moving around, away from the speaker icon, because I can't see this? Can you still hear me?
No, it works.
Okay, awesome.
Everything is fine.
Awesome. So yeah, just as a bit of an overview of our lab. So of course, I'm not doing my research on my own. So there's like a really nice bunch of people involved, and I saw already a couple of them sitting in the audience. So that's very good to see. I had like 4 PhD students, master student, a couple of interns, research students, and research assistants. And all of them are very much interested in the idea of extending realities using AR or VR in some ways. They are all working on different topics, but we share this kind of common interest in immersive technologies and extending realities. What you see here on the right-hand side in the middle is a 3D reconstruction of our lab. So basically during all these kind of times of having lockdowns, we also try to create some kind of more immersive environments to share the idea of going into a shared lab space and having our meetings there. So we tried a couple of different options. We didn't try Gathertown, but we had nice experiences with OEA, for instance, and also did a couple of 3D reconstructions of the lab to just provide this kind of feeling of being together. So, but what I want to talk about today is this kind of idea of how the way how we're accessing information has changed over time, and also how AI and AR, XR technology can basically help us to make more use out of this. So if we just look back into a couple of years, or more like decades, back in the days, it was quite hard to access information. So you often had to go to a library, and then you had to go through all this kind of information and search for certain piece of information that you're interested in. And this actually changed quite a lot. So particular in the last weeks, I think like lots of people were experimenting with GPT and basically try to access information using this new technology. So basically like the way how we're accessing information changed quite a lot in the last years, and in particular also in the last couple of years. So for instance, if I'm now interested in learning more about the recent developments in computer graphics, I can easily just type this kind of question into the chat, and basically then asking, give me a summary about what happened in the last couple of years. However, this actually then also brings some kind of disconnection, because what happens a lot is that people now are really stuck to their mobile devices or to their screens, and there's always this kind of notion around having zombies, so people that are walking around with their mobile phones and just being focused like a zombie. And this is basically like one of the risks that comes with this kind of ubiquitous access of information that we basically have all around us all the time. And what we can basically do, and there's so it's like a really huge potential that comes with XR and augmented reality interfaces, is that we can bring this kind of connection between the information and the physical world around us back into our daily lives. So, for instance, there's like a small example here on the left-hand side. This is obviously like a generated image of a person wearing a see-through headset, and then on the right-hand side we basically see a screen with guidance, navigation information provided by Google Maps. But if we think about this idea of bringing those together, we have like a huge potential, because we can actually have both in one place. So you still see your surroundings, but you can still access information that you're interested in about your daily tasks, like navigating a new town. So, and this idea is actually not new. So there is already this kind of really interesting concept of the word board that Sporer, so James Sporer, was working for IBM, was proposing end of the 90s. And he was basically writing about this idea of what if we could put information in places? More precisely, what if we could associate information with a place and perceived the information as it were really there? And this is quite interesting, because this is actually this kind of idea of bringing information to the place where it's actually being used by the user. And what you see here on the right-hand side is a really interesting concept, and I will later on come back to this concept, because this was also covering lots of my own research when I was doing my PhD. So what you see here on the right-hand side is basically the construction site, and there are information about pipes and some additional information about like a warning and what happens around this kind of construction site. So Sporer was coming up with this kind of idea, of this kind of concept already lots of years ago. And this is quite interesting, because if we now think about the potential and this kind of ever-growing amount of information that is available to us, having a interface that provides this information more closely to where we need this actually can be quite helpful. And it's, this sounds a bit like I'm talking about the future, but actually this is already happening. So if we just think about indoor augmented reality applications, this is already there. So we can already place furniture, we can use augmented reality to measure our rooms for further planning. So there are already lots of applications, and also you can place spiders into your living room, test out a Christmas tree here with a Snapchat filter, or you can play with the small caterpillar in your living room. So all these kind of things are already there, and we can basically put information into the right place. In this case, the information would be the story around the little caterpillar. But if we think about large-scale environments, there are still plenty of opportunities, but we don't really see too many applications there at this stage. But we still have like plenty of opportunities. So for instance, think about a construction site worker who has access or needs to access data and plans. You might want to have a look into what kind of pipes are buried under the ground. All of this is still often happening either on a, maybe still even on a paper plan, but nowadays mostly on mobile devices. But there's still a bit of a disconnection between what's actually happening in your environment, and users have to do this kind of spatial mapping to their environment. And also, if you think about other activities, so for instance, going into a sports stadium and watching in this case, a rugby game, often people will wonder about where is this kind of additional information about the game? I only see the action on the field, but there's not so much additional data unless I'm taking out my mobile phone, looking up certain statistics. So there is a lot of opportunity in this space to also provide information on site and where it's actually needed very similar to the concept that James Borrer was describing. Other applications in large-scale environments are, for instance, tourism. So if you think about tourism applications, people are already using their mobile phones quite a lot. So they basically, you have your mobile phone with you all the time, and this is often used for accessing information, but also for taking photographs, capturing memories. So there is like a lot of opportunity to also use this as an interface for displaying additional content. So for instance, think about this kind of idea that you can access information on site. So you're taking out your mobile phone, you're pointing this towards an interesting tourist site, and you get information about what you're actually seeing there, maybe some kind of additional facts about the history, or another option could be that you even use old photographs to travel back in time. So this is like a small prototype that we built here in Otago. What you see here is our university clock tower, basically like an old photograph, and then being overlaid onto how the campus looks nowadays. So the idea is that basically you can go on site and look back into the past, which is very different to the experience of just taking out a photograph and trying to map this and just make this kind of like relationship between the your surroundings and the photograph, which often requires quite some additional thinking and cognitive workload. So the idea is basically here that you could just go there, go onto the campus, and then explore a couple of old buildings and look or explore them how they looked in the past. Also, we have this kind of opportunity of extending the world into an interactive space. So we can, not only use augmented reality to access data, but we could even interact with other people that are sharing the same space with us. We could use this for connecting with them, sharing emotions. In this case, basically what we have here is some emoticons that are displayed based on the feelings of other people within the stadium. So what I would, basically those are some kind of opportunities. And what I would like to do now is I just want to talk about two different scenarios. So basically these kind of scenarios are following me since I was basically starting with my PhD studies in Austria, in Graz. And I just want to give a bit of more details here, what these kind of scenarios are. And then we will just have a bit of a look into what are the opportunities and what can we do also in terms of the challenges for these kind of scenarios. So the first scenario I want to talk about is basically using augmented reality for civil engineering. So construction site planning, architectural purposes, information querying, planning applications, and all of these kind of tasks are often involving quite complex data. So there's like a lot of information involved that is related to a certain place. And basically, one application here would be to query information where you want to know more about a certain pipe that is buried under the ground. And what you can see here on the left-hand side is basically that people or construction site workers, they would go onto the construction site with some plans and then trying to look up this information. AR could basically be used here to directly display this onto the field of view of the user. We can also use augmented reality for planning purposes. So instead of just working on the screen, we could basically display newly planned objects. In this case, we have a couple of light sources, and you could basically just visualize them directly where they're supposed to be. And this helps the construction planners to really get a bit of a better understanding where these kind of objects are located. But also this could be used for surveying. So instead of surveying just a couple of points with your with your measurement device, you could actually use augmented reality to just do this kind of surveying directly in place. So you basically point your device directly onto the points of interest in your environment, and then using this for measuring certain objects of interest. But then also, having this kind of ability of exploring or capturing how a construction site developed over time is quite important for construction site management. So often construction site managers, they want to go back in time and maybe locate where a certain problem was occurring. So having like a mean of constantly capturing data about a construction site will help them to explore these kind of different steps in the progress. And also here, augmented reality can actually help us quite a lot by not only, capturing photographs that are, maybe unstructured and hard to follow. What we can do is we can actually use this for creating, for instance, 3D reconstructions, but also using visualization techniques in augmented reality to visualize the progress of the construction site over time. What you will see here on the right-hand side looks a bit old school, I would say. This is basically because when I was doing this research in I think 2010, the photogrammetry methods were still not that great. So if you look into more modern techniques nowadays, you could actually even achieve much better results here. So this is just like a bit of a note, but the idea is the same. Like you can basically use augmented reality to display different stages of a construction site by just embedding this directly into the field of view of the user. Then the construction site manager can go back and explore what was happening on the site. So this was the first scenario, and the second scenario I would like to talk about is AR sports spectating. And the reason for this is that like lots of my research is around this kind of sports and how we can support sports spectating, but also training and coaching. And AR basically has like a really huge potential in this field, and we often have to work around the challenges that we work with, like a really large environment. And lots of my research is centered around this topic. So for AR sports spectating, we have like again lots of data. So if you look into data that is related to a soccer game, so with the World Cup, for instance, like there's like a lot of data that is basically related to each game, but also about the histories. So what we basically have is like a huge potential of data that can be visualized and is also already getting accessed by spectators, but not on site. So we have, for instance, game statistics. Maybe people are interested about, what is the ball possession over time? How are these kind of statistics changing? And maybe you're interested in some event data, so where are often penalties happening. In this case, in this example here, we're visualizing tackles, which is something which is very typical for rugby. But you could also just imagine this to be like a visualization, like a spatial visualization of where were occurrences of penalties during a match. What are locations that are often covered by the players, and all this kind of data has already like a really interesting spatial component. And this means if we take this now and display this in augmented reality, we can actually support the spectators on site in a really good way. But it's not only about data that has been captured already, also replays that we are really used to from watching television, sports on television and broadcast. In AR, this has like a new potential, because we could actually imagine to have AR replays that are just produced for our own perspective. And this comes with a big challenge, because obviously there is no good camera placed for every spectator, which is in contrast to what's happening with broadcast cameras, that we capture lots of interesting content. But actually we can use computer vision and machine learning to extract 3D representations and use them for AR replays. So what you see here on the right-hand side is basically 3D reconstruction that is based on a paper which is called Soccer on a Table. And what we are doing is we're visualizing this now on a small sports field here next to our campus. And then you can basically just go back and watch this as a replay. But you could also think about this to be integrated into the live game. Also, we can use augmented reality as a matter of situated commenting. So instead of just seeing comments about a certain event that's happening during the game, we could basically directly put like a spatial annotation into the field of the view of the user to show where this event was happening. And this can really help them to understand the actions on the field, getting some explanation, in particular for people that might still try to understand the rules of the game. This can be really valuable, but even also for expert users. Okay, so maybe then the question is a bit why are we not seeing this more often? I know that there was a bit of a demonstration around using augmented reality in the stadium in the FIFA World Cup this year, but it's certainly nothing that you can just use. You just go into the stadium and you have your phone taken out and you see some kind of AR. So this is still something which is quite challenging. And the challenges I want to talk about today are basically the localization and tracking challenges. So how can we figure out where a user is located in the stadium? Then also around visualization challenges. So for instance, if we talk about visualizing content on a small mobile phone screen or even like an optical see-through headset, we have like way more restrictions compared to displaying information on a big computer screen or a television screen. And then also the last challenge I want to talk about is actually data set creation and user studies in this space, because there's certainly a big difference of running in-lab studies for small space, which is very close to what you would basically then also have in your actual application, compared to if you want to take these kind of applications out into the field and running studies and on site. Okay, so we'll just start with the localization challenges here. And so for augmented reality, we often basically need to know where the user is looking at. So we need to have like really good information. We call this pose data. So this means that we know where is the user located and where are they also looking at. So what is their orientation? And this is already a challenge in smaller spaces, but I think nowadays we have pretty good solutions for this. So there, you can actually use AR in small spaces and it works really nicely. And if you haven't tried any of these kind of AR applications before, I highly recommend to just have a bit of a play with this, because it's actually quite a lot of fun. But outdoors, this is basically still a bit of a challenge. And then I'm now just looking back into how did we localize users in 2012. So it was basically when I was doing my PhD. This was even a bigger challenge outdoors, because the mobile phones back then didn't really come with these kind of really nice sensors that we have nowadays. So what we did in 2012 was basically coming up with a custom solution. So we used a tablet PC, then extended this with a Xsense IMU for basically getting orientation data. We plugged in a nice high quality camera, because lots of these kind of tablets didn't have a camera at all, or they had just like a very low resolution, low quality camera. And then what you can see here on the right hand side in the top image, there is like a huge antenna coming out of this tablet, and this is basically for the GPS receiver. And this is basically something that helps us to provide really nice, accurate information about where is the user located, which is very important if you're going outside into the field and you just want to display content that is spatially nicely aligned to what the user is seeing in their environment. You need to know exactly where they're located. So this was our solution in 2012, and luckily things changed quite a lot since then. But back then we were very happy with the results that we could achieve. So we were really able to display building outlines and pipes and manholes, all this kind of data that is really important for construction site workers in a very nicely aligned way. So sorry, I'm just briefly checking back into the Getter town. Sorry. Oh, where am I? Sorry. Just briefly checking. Are you still there? Sorry, I just need to. Is it all good? Okay, awesome. I just want to see if people are still there. It's a bit weird because I can't see you. Okay, sorry. I'm going back to my slides. So basically, so this was what we did back then, and we then also looked into other options for basically figuring out where is a user located outdoors and displaying AR content in a nicely aligned way. So we were then looking into model-based solutions. So for instance, by capturing lots and lots of different photographs, computing a 3D reconstruction of the environment of interest to create a point cloud, and also for each image pose data. And this was then used in order to send an image to our pose estimator, and basically during runtime of our AR application, we were sending these kind of images to the application. We got a pose data back, and this then helped us to display AR content. But obviously this was involving lots of data capturing. So back then we were using a drone to basically cover the area of interest, and then capturing lots and lots of different photographs. Also Jonathan Ventura, who I think is also attending the conference, but I haven't seen him, and I work closely together with him. He back then also looked into lots of different options for capturing large areas of interest and then using this for mobile tracking for augmented reality. So this already gives you like a nice, nice solution, but it's basically involving like a lot of effort in terms of capturing a scene, and also it's basically very sensitive in terms of if you have dynamic environments, so if the scene is changing quite a lot. So, and this basically brings me to the question of how about a stadium, because if you look into stadium environments, they will change a lot during the usage of your application. So first, there is no way that you can just go into a stadium during a game is running and capture lots and lots of photographs to then just use this for your pose estimation algorithm. So what you need to do is basically you need to capture an empty stadium beforehand, and then you need to be lucky that the pose estimation is still able to handle this data and is still happy with the changes, because the environment will change quite a lot. So luckily there are a couple of newer developments nowadays. So if you're now looking into the options that you have, for instance, with using LiDAR scans, this is an example that we did with Snapchat's Lens Studio, where you can actually just create a LiDAR scan of your environment of interest. So in my case here, I was capturing our local soccer field and then using a LiDAR scan to myself and basically the AR content using the Snapchat application. Also use this, for instance, as part of the Lightship SDK. So this experiment that one of my students was doing of a playground area. And also here, basically, we used the LiDAR scan of the environment of interest, and then basically came back and displayed some kind of AR content by using this. But obviously there is a challenge here, because the LiDAR scans will only give you information over a certain distance. So you have this kind of 5 meter range that the application is covering. So in order to then avoid these kind of restrictions, we actually looked into using an approach that is called the expert sample consensus for localization, ESAC. And this is basically based on work of Eric Prachman. And what we did, we were basically now taking this into the stadium, and we captured again lots and lots of photographs of an empty stadium. and then use this kind of data, so like all the kind of photographs that have like their pose information attached, by running this through a structure for motion application. And then we use this for basically training this kind of expert network. And we were interested in how well would this actually work once the environment is changing. So what does it mean if we now run this kind of expert network during a live game? And so one of my PhD students, she was looking into this quite extensively, doing like lots and lots of different tests, also in terms of the accuracy that we can achieve, creating reference points in the stadium environment, and then running basically this approach with different levels of crowdedness, and really looking into the possibilities that we can, or the opportunities that we can achieve here. So what you see here on the left-hand side on the bottom is basically a bit of an overview what kind of reprojection errors we can achieve. And reprojection errors are quite important for AR because they basically tell you a bit how much is your 3D content off once you're displaying the 3D content as an overlay in AR. And we were actually quite happy with the results that we achieved here by basically achieving accuracies around 11 pixels, so like 11 pixels offset on a 2048 width image, so which is not too bad, and it's still okay in terms of displaying certain information in an AR application. It's important to mention here that obviously the more you train your networks, the better the quality actually then gets, and the better results we can achieve. So in our case, we basically used 10 expert networks and then trained those and achieved this kind of accuracy. But obviously, if you use less, the accuracy goes down. Okay, so this basically means once we figured out where the user is located in our challenging environment, so for instance in the stadium or on a construction site, we can then go ahead and visualize data. And again, as I was saying before, this is not as straightforward as you would do, for instance, on a large screen. So in particular, in outdoor environments, we come with this kind of challenge around information clutter, because a lot of these kind of environments are already quite cluttered. So of course, I used like a worst case example here on the left-hand side, which I think is in Hong Kong. So this is like very cluttered, but even other environments. So on the right-hand side, you see like the one of the places in Graz. Even there, you have like lots and lots of information that is basically part of your actual environment. But also, if you then display information like OpenStreetMap data that is related to this certain place, this will add to the information clutter. And then we have maybe like complex spatial relationships. So in this case, what I was trying to do was I was basically just displaying lots of OpenStreetMap labels, so information about certain buildings that are related to our computer science building here in Otago. And if you just just put them out, you just render them, it's not very helpful. So, nobody will now know what's your FEO building, what is the Robertson library, because some of these kind of labels of buildings are actually not visible from this perspective. So we have also to take these kind of spatial relationships into account to make sure that our visualization is actually making sense for the users that are working with this. So what are potential solutions? What we can do here is, for instance, we can use data or scene understanding about our environment. So for instance, in this example here, I was using OpenStreetMap building outlines to just make sure that our data is aligned to the buildings. But we can also go one step further and really look into scene understanding in terms of using segmentation methods and just making sure that the data, the labels are only displayed at certain positions that are really related to the content that we want to display. But then also we sometimes need to integrate additional visual cues. So for instance, for some of the applications that I was talking about before, we might even visualize data that is not really something that we would usually see in our daily life. So, if I'm walking along a street, I wouldn't see any underground pipes because they're just not visible to us. So this means if I'm just displaying them as an AR overlay, this would certainly not really make sense to me and as a human user. And this means what we need to do is we need to use our AR visualization techniques to support the user by providing them additional visual cues. So for instance, integrating some kind of 3D content that might give them a reference how deeply, for instance, pipes are buried. Or if we talk about other information, so for instance, labels about certain objects or certain places, it might be helpful to integrate cues that we are already used to as a human from our visual processing. So for instance, including shadows could help us to get an understanding where certain floating object is placed in the environment. And we have similar challenges in sports as well. So for instance, if you look into this example here, you will notice that there are certain things slightly off. So we have a couple of people that are covered by the lines on the field, but it's not really something that would happen in nature. So also here, if we just display a heat map, it doesn't really look too great. So we actually really have this kind of interference between real and virtual objects that we need to take care of. And also, again, here, we have actually a lot of information clutter and need to decide what kind of data do we want to visualize during a game, for instance. So potential solutions here, again, we can look into scene understanding. So for instance, using instant segmentation to figure out what are objects, what are persons, what is the field, and then integrating this into our rendering techniques. But also we can use basically the context of the user and analyze the context and the environment of the user to find really nice positions that can basically be used as display areas. So if you go to a match, to a game, you don't want to have all your players being occluded by information about the game. So you really want to keep the field clear and then only make use of the areas that are not really of interest to the spectator. So for instance, the opposite spectator stands, maybe the banners where you have usually the advertisement, which will maybe just bring a bit of a trouble with the advertisement rules. But these kind of areas that are not really very important for the spectators could be used in terms of displaying additional content. But you just want to keep the actual action free from occlusions. And basically what we can do is we can now use 3D models of the environment to find suitable spaces, but we can also basically just use image analysis to just make sure that we identify suitable spaces that are not really relevant to the user and can basically be used to display additional content. So in our case here, what we're doing is we only display data on the field, just in these kind of areas that were not really covered by players. So those are basically solutions to avoid these kind of challenges. And also, we had this kind of example before, where we just display emotions that are related to the game on the opposite spectator stands, because they are not really important at this stage and can be occluded by this kind of graphic. Okay, so this was the visualization challenge, but also it's a bit of a challenge around creating data sets and experiments and user studies in these kind of environments. And this is what I would like to talk about next. And if you look into this first example that I was talking about the construction sites, what we did back then was we actually had a drone, and the drone was programmed so that it's capturing a really good coverage of the building of interest, and then we basically collected lots and lots of data of this environment, and then in order to now use or like run user studies, we often developed first tests for in-lab usage, because this often helps you to create some solutions and test them, because it's often quite hard to go outside and test your solution in a construction site. There might be some kind of rules involved in terms of accessing a construction site and testing this. So what we used in this case quite a lot was using indirect AR. So indirect AR is a concept where you, instead of having like a full AR application, you basically work with 360 footage, and then you use this for simulating an AR experience. So the user, so for instance, in a user study, they can still move around their mobile phones and get this kind of perception that they are within this AR environment, but they don't have to go outside, which can be quite helpful in terms of running first lab tests and implementing certain visualization techniques without having the need of going forth and back between the lab and the environment. But lots of things you can't test if you're not actually going outside. So for our project with the construction site workers and construction site managers, we actually had to also collect feedback from domain experts, and basically in this case this was from civil engineering companies. So like there was like the Austrian railway company and a couple of electricity companies from Austria that we worked with back then. And what we were doing, we were basically visualizing different types of urban geospatial data, so GIS data. And what we collected back then was actually getting like really good feedback about the AR visualization techniques. But I have to say this was basically like just like a small audience, and obviously you need to go back and evaluate this with like a larger audience. But there's often this kind of challenge with having a few domain experts and then going back and creating new solutions that are adjusting to their needs. So there's certainly an additional effort required in this step. For the stadium scenario, we also had this kind of challenge around creating like a good data set, because what we needed to have is actually like a really good 3D reconstruction of the environment that we want to use, but then also having a mobile phone sequences that are creating this kind of, or simulating this kind of impression of being within a stadium environment, just for testing and running experiments, in particular for the localization techniques. So we created this kind of setup where we had basically like different sensors or mobile phones attached, and this basically gave us like a really good ground truth setup. And we use this for a lot of the computer vision technique evaluations, but also for the user experience, we were looking into different options of evaluating these kind of techniques in a smaller space to just get started with. And what you can see here is basically we built like a small miniature stadium version, and then conducted a couple of user tests within this environment. But then obviously lots of the challenges or lots of the research questions can only be answered once you're really going outside and testing this in the actual working environment. And we were actually quite lucky in terms of conducting our first experiments in the lab, and then using the same results in the stadium environment, and lots of the results were basically nicely transferring into the large scale environment, which was really nice for us to see. So what we basically evaluated back then was looking really in this kind of idea of, can AR, augmented reality, situated visualizations in this case, increase the overall game understanding, and also achieving like a similar game satisfaction, like being basically on site without any additional devices. We also found that there was a bit of a lower fan fanatism, which might be related to the fact that they were actually focusing more on using these kind of devices, which is often like a critical point here. So like lots of people were basically also mentioning that it's not really handy to have like a mobile phone that you hold up all the time, and certainly for future work, using head-mounted displays would be like a nicer option for this, to be less disturbing. Okay, so this also already concludes my talk, and I just want to briefly mention a bit the lessons learned. So I think from my perspective, working in this area, I think there's still lots of open challenges, in particular for these kind of large scale environments. And I don't think that all of this is already solved. So there's still lots of research potential. And I think there's lots of opportunity for using machine learning techniques in order to support XR and in particular AI applications and help to create these kind of novel interfaces that are embedding data and information more seamlessly into our daily lives. And I think we're getting closer to this kind of idea of what Spora was proposing around putting information in places and then presenting the data that is relevant to the user and their context. And finally, I think also running AI user studies, it's still a challenge because in particular, if you want to target these kind of large scale environments outdoors, there's a lot of logistics involved in terms of going forth and back between the lab, your development environment, testing something. So this is still something where, we can basically create new methods in terms of running better tests and better studies. And I didn't cover all the relevant topics here today. So there's lots of other stuff that is going on in the space, like displays, collaboration, offering, where lots of other amazing people are working on. So with this, I would like to conclude my talk, and I would like to thank all my supporters and colleagues that I've worked with in the past, and also all our project partners. Thank you very much.